Hello, my name is Rich Howard, and this project that we're going to use the CNC machine for is creating custom ceiling tiles for a client. We're going to turn off all of the accessories till we figure out what's going on here. Something's not right. We're telling it 1212. We're positioned in 1212 with a home position of 0, so maybe we're killing the toolpath before it has time to go back. So let's delete this. Let's create a new pocket. It inherited our original characteristics. The home position we want to change. So let's make this 0, 0. Okay. Our vector is selected. We're not doing a profile, so let's exit that. We're doing a pocket 1, 0, 0. Save Z is 0.2, that's fine. There's nothing on top of the work. Calculate. So what's interesting is it started in the center of the piece. This has got to be what our problem is. Our XY datum position. That's got to be what the problem is. And admittedly, I've never, yeah, that's what we want. I've never played with changing the datum position, so that would explain why I'm seeing something that confuses me specifically. So reset preview. Preview. Yeah, it does your cutting there. That's expected. But what we're seeing here now, though, is preset preview. So the red is where the tool comes from. So this makes sense. So my problem was in setting the datum position. Okay, so let's close. Let's save the tool path. Let's test. Let's overwrite the test pocket. Let's pull up Shopbot. Let's air cut and see what happens. So we're at 0, 0 right now. It raised to a safe Z height. Spindle on. Now, what it should do, and I'm not going to record this, but it should move to 1212 and start its cut. Okay. Now I think we're ready to cut that part. No offset. So now what's going to happen is I'm going to turn on the vacuum. I'm going to turn on the dust collector and then turn on the spindle and start. Turn us back to we're going to resume and let's see what happens. we're going to alter what we're doing with these values. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Start, enter. That's why I wanted to leave it there, so you'll be able to see the edge work. I didn't turn on the dust collector. You can see right with the clamps, we're not going to hit them at all. I'm going to start in the second pocket. Turn on the dust collector. That I was lifting to a much higher Z-axis. Yeah, that looks great. So I just 1/8 inch, 1/4 inch, 3/8, 1/2 inch, 5/8. So now we understand how that works. Just ignore this. That's from our prior work. The bottom line is I couldn't duplicate this on this board because this board's only 1/2 inch thick. Neat. Now we understand how that works so that we can more efficiently create this by not having to air cut so much. That was the point of all of this. Okay, so we've got a good understanding that the bottom line is the reference point of the tool path is from the material surface. So if you're going to tell the tool, if you're going to tell the operation to start at a particular depth, you're already telling it, you're telling it in reference to the material surface. So to me, what that means is material surface. If you're telling it to start at 1/8, it'll start at 1/8. And if you're telling it to cut 1/8, then this is going to be your finished dimension or your finished depth. If you're telling it to start at 1/4 and then cut 1/8, you're going to have 3/4 here. Well, pardon, 3/8 from here down to here, and so on. All right, so great experiment. Let's not save those changes, no need. Let's cancel, let's open. And that was version 2 with a 3/4 end mill. Okay, so outside profile, outside perimeter, that's the only tool path that I have. So set, we've got our thickness, starting at this datum, material surface, 00 home. Okay, cancel. Let's preview that. All right. So that cuts through. Great. We are going back to our profile. Our depth, we've got our bit. I do want to change this to 5. So I want to hang on to it. I'm going to change it to 6, actually. 5/32. 5/32. So we want to be on the right side, that I know. We're going to want a conventional cut that. Ramps. Yeah, we're going to ramp into it. Right on. We know it'll cut through. In this tool path, we're going to end up putting it at the very bottom of all of our tool paths, of which there's going to be 4, 7, at least 7 I can think of for sure. And we're going to end up dragging that to the bottom so it does this last. And in fact, what we may do is simply delete it all together. Yeah, we're going to, this won't be the profile. The profile we're going to make is going to be a much bigger profile. The profile cut that we'll make. So this profile cut's actually not going to exist like this because we're going to work the entire sheet at one time. So our profile cut is probably going to be around the profile of it, or start here, come down, across, up, over, that kind of thing. So yeah, that's going to end up getting changed. Okay, so now what we need to do is create a profile cut with the 1/8 inch ball nose, pardon me, the 1/8 inch end mill for all 3 of these. That's the next thing that we need to do. So let's save this. We're going to break, probably going to be a week or so before I return to this. It's saved, and we will pick it up when I get the bits is when we're going to we're going to return to this because we'll end up drawing that. We'll end up finishing this tool pathing. Um, but we're going to do the entire, no, we'll probably do the entire sheet, and then we'll test part of it with the smaller bit. We've got an automatic tool changer coming, but it won't be installed by the time I run this. So we're going to have one tool change. It'll be two different tools. Awesome. Let's keep going. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Let's move on to the rest of the video. So it's been a couple of weeks since this project had any forward motion. So where we are now is I ordered a 3/4 inch shank, 3/4 inch end mill, and the collet doesn't fit in my tool. Even so, I have reordered a 1/2 inch shank, 3/4 end mill. I've also ordered well, let me just grab it and show it to you because I have it here. An Ansrud 52-240. This is an 1/8 inch end mill, and oh boy, I'm realizing it might be a bit short. Jinkies, it's too short. I'm not going to be able to get through 3/4 MDF with this 1/8 inch end mill. Let's take a look and see what Ansrud has in terms of an 1/8 inch end mill. I have their catalog and I'm just looking at it now. That was a 52-240. And the reason that I want a small end mill like that, yeah, it's too short. Yeah. Yeah, the length of cutter is inadequate. So, they've got a 1/4 inch diameter. And the reason that I'm going with that is because I want to get 8 pieces of these ceiling tiles out of a single sheet. Um, and I'm going to make a single profile pass to separate the two pieces because that edge doesn't matter. It's completely concealed. But as I look at what tools I have, a 1/4 inch end mill is going to work because it's going to work just fine. Calculator. I actually have, well, let's just say 96. Uh, let's do this. 23 13/16 times 4. It's 95 1/4. So if I come with a 1/4 inch end mill, that's that's 1, 2, 3. And my sheet's 97. And my tool will go to 97. So a 1/4 inch end mill is going to work out just perfectly. And I have a 1/4 inch end mill. It's not an Ansrud, it's a Amana 46415. Let's look that up. That is a 1/4 inch diameter, 1 inch cutting height, 1/4 inch shank end mill. Spiral. It's a down cut. Not what I want. I'd like an upcut because it's MDF and MDF. I've noticed that MDF likes to sit in the chips or the very heavy particle dust that you create with MDF likes to sit down there. And I'd like to do an upcut. We're going to experiment with it before I buy another bit just to profile cut that because of what it is. And I'm going to do it in multiple passes anyway. So I'm going to use that 1/4 inch end mill that I have. Okay, so let's move on. So what we're going to do now is start tool pathing or creating the drawing, then tool pathing for 8 ceiling tiles per sheet. And this is where we're actually going to learn how to copy array copy toolpath, I think is what it's called. I've never done it, but we're going to figure out how it works. because I'm not drawing it 8 times. We're going to do it. We're going to draw it once. We're going to then set that into an array. So let's switch to the screen view and let's break a leg. Okay, so we checked the height, we checked the width. We know that we believe we've got stuff in the right place. What's going to happen is the vector on the outside is going to end up being a profile cut to the right of the line. Everything in the center, the 3 vertical and the 1 horizontal, are all going to be profile cuts on the line with a 1/4 inch on mill. All of this will be 1/4 inch on mill. Now, we're not going to draw those vectors. I just want the guidelines to be there. We'll do those after, because now what we're going to do is create the tile, and then we're going to learn that copy path array situation. So let's do that. If you've made it this far into this video, you must be determined to see it through to the end, and we appreciate your hanging in there with us and watching this entire video. Okay, so what I'm going to do is I'm going to change the material setup temporarily. I'm just going to make it 24.5 by 24.5. So all I'm doing here is just making it look balanced so that when I draw this next tool path, it'll look a little bit cleaner on what we're working on. Okay, it just looks more balanced is the bottom line. So we know the OD is going to be the overall width and length, so to speak, is 23 13/16 minus 1/8 of an inch over here because of how that bit's going to come through. Okay. Over here, same scenario. Should be 23 15. And it is. Okay, so this is good. The next guideline needs to be at a particular location. The issue is, once again, I don't recall how wide that first line was, meaning what the reveal was. And the and the ceiling tile that I made is up in the ceiling, so I don't want to get a ladder and go pull it down. So let's close this file. Let's open up the original 3/8, and then we're going to measure how far over from the hard outside corner I left the reveal, which is this dimension here. 11/16. Okay. 11/16, and these were 3/8. Yeah. So we're going to create a new guideline, relative 11/16. Now, this one, we're going to need a new guideline, relative negative, not 11/16, but 13/16, negative 0.8125, because that is going to account for the kerf of the bits. close. So this is going to be 11/16. This needs to be 13/16, and it is. Okay, that's good. So now let's do the same up at the top and the bottom. So the bottom's going to be easy because that's a outside profile cut relative to guide 0.6875. Create. This one is going to be relative to guide negative 0.8125. Create. All right, now from here, we're going to make our steps. I think what we did was we moved them. We should have copied them. Copy to pocket. Turn that off. Yeah, okay, now they're there. Turn it on, turn it off, turn it on, turn it off. Okay, so now I've got vectors for pocketing. I've got a vector for profiling. So it's all about the radius corner. I'm going to have a 3/4 inch diameter bit pocketing all of that out, but I don't want a 3/8 radius in these corners. I want to see 0.0625. I want to see a tiny radius. So small, you're going to think it's square. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Okay, so what has to happen now is we need to run this tool path. And if it works, we're then going to explore how to use array copy toolpath and plop it into those other 7 spots. And if that's good, then we're going to production, is the bottom line. I don't have the bits. I don't have the 3/4. I do have the 1/4 inch on mill, and I do have the 1/8 inch on mill, but I don't have the 3/4. I'll have that by next weekend. So at that point is when we are going to we're going to cut this first. There ought to be 2 tool changes through it, and then we'll see what the machine does. So that's where we're going to break this. Everything is so far so good, looking good, and we'll see what happens. Till next time.